we're going to be talking about something really similar to what we did yesterday. So yesterday we solved equations that had square roots in them. And to get rid of square roots, what did we use? We used squares. So today we're going to see equations that have squares in them. And to get rid of a square, we use a square root. Okay, the steps that we're going to take are going to be really similar to what we did with solving equations with square roots. It's just going to be the opposite to get rid of the square instead of the square root. And then we also want to keep in mind that our answer is going to be a little bit different. We're going to end up with two answers when we solve equations that have squares in them. All right, so let's just write down the steps here. Just like what we did yesterday with the square roots, we're going to put a box around the square because we have to get that by itself before we can get rid of the square. So we're going to put a box around the square and then use the golden rule to get the square by itself. Once we do that, we're going to take the square root of both sides to get rid of the square. Now, this is where it gets a little different. If you compare this to yesterday's notes, up to this point, it's almost identical. So yesterday we boxed the square root, then we used the golden rule to get the square root by itself, and then we took the square of both sides to get rid of the square root. So it's the same thing, we're just flipping square and square root. All right, so now it's going to be different because when we have a square, we're going to get two possible answers. So we're going to write another equation at this point with the negative square root also. So like in the opener, we saw that where when we took the square root of 9, we got positive 3, but we also got negative 3. So we wrote two different equations at that point. Once we've done that, we're going to solve both equations and get an answer for both of them. So in the opener, we were already done because we didn't have to do anything else to get the u by itself. But sometimes when there's more than one thing in the square, we're going to have to do some more to solve. So we're going to continue solving both equations. So we'll just do one at a time and get two different answers. All right, so let's look at some examples here and see how we're going to use this. So this is a pretty simple one to start with. We do want to make sure that we do all of those steps to start it out. So we're going to circle the variable, draw the line of equality, and then we also want to box the square. So I'm going to put a box around the square here, but not just the square. I'm not just going to do this, but I'm going to put a box around the square and anything that it's squaring. So the box for this one is going to go around the a also. All right, do not just put the box around the 2, the exponent, but anything that the exponent is on. Now, am I going to have to get rid of anything to get that square by itself? Is there anything outside the box that I have to get rid of? No. So the square is already by itself, so we're done with that. So then the next step is to take the square root of both sides to get rid of the square. So I'm going to take the square root here, and why am I taking the square root? Why did I put a square root on there? To get rid of the square, right? So I'm going to put a square root on the left side, which means I have to put a square root on the right side. So I put a square root on both sides. On the left side, what does that square root do for us? It cancels out what?
Square.
It cancels out the square, right? So the square root and the square are gone, which leaves what? The a all by itself. All right, on the right side, what is the square root of 25? It's 5, or it could be what?
Negative.
Or it could be negative 5. So we're going to go over here and we're going to write a equals negative 5. Now, is there anything else I'm going to have to do to solve these equations?
No.
No. So these are going to be my two answers. I get a equals positive 5 and I get a equals negative 5. Okay. Got to use both. We got to give both answers. Now, a couple of things about this. Since there's nothing else to do to solve either one of these, then I can just put a box around them and I'm done. But sometimes I'm still going to have to do a little bit of work on both of the equations. And when I do, I'm going to want to draw my line of equality for my new equation and solve that like I normally do. All right, since there's nothing else to do, though, I don't need that line of equality. I'm just going to put a box around both. So anytime we have an equation with a square in it, we're going to get two different answers. Why is it, before we go on to the next one, I just want to make sure we're clear, why is it that negative 5 works here? Why is negative 5 an answer?
Because it
when we plug negative 5 in for a in the original equation, negative 5 squared means negative 5 times negative 5, which gives us positive 25. So negative 5 works for a here because when we multiply a negative times a negative, we get a positive. All right, next one. This one's pretty similar. Not exactly the same, but pretty similar. So I want you to try this one on your own before I go over it. So I'm going to circle the variable, draw the line of equality, and then the other thing that we want to do, since this has a square in it, is we're going to put a box around the square, and then also that box is going to go around everything that is being squared. All right, so this time there is something outside of the box that I need to get rid of, right? Why is the negative 1 not inside the box? The negative 1's not inside the box because it's not part of the square. The only thing that's part of the square is the b. All right, so since it's not in the box, what am I going to have to do first? Get rid of that minus 1 by adding 1, right? So we're going to add 1 to both sides. And on the right side, when the 1's cancel, what does that leave? B squared. And on the left side, 3 plus 1 is? 4. All right, now the square is by itself, so what do we do to get rid of it? Take the square root. So we're going to take the square root here to get rid of the square, and then if we take the square root on the right side, we have to take the square root on the left side. So on the right side, what's going to happen with the square and the square root? They cancel, which leaves what? B. On the left side, what's the square root of 4? 2. Or it could be negative 2. So we're going to go over and we're going to write another equation, negative 2 equals b. So we're writing the exact same equation over here, but we're putting the negative in front of the 2 instead of a positive 2. Is there anything else we have to do to solve these? Nope. So those are your two answers. B equals 2 or b equals negative 2. And both of those answers will work. All right, next one. I'm going to circle the D, draw my line of equality. Now, on this one, when I put a box around my square, what is that box going to go around? What else needs to be inside that box? What's in the parentheses, right? So that whole parentheses is being squared, so my box is going to go around that whole parentheses. Is there anything outside of the box that I need to get rid of? No. So then I can get rid of the box, get rid of the square by doing what? Take the square root. All right, so there's nothing that we need to do before we do that, so we're going to take the square root on the left side, and that's going to get rid of the square. Notice that my square root covers the entire box. Everything that's in that square, we're taking the square root of. All right, now if I take the square root on the left side, I have to take the square root on the right side. So on the left side, the square and the square root cancel each other out, which leaves what? D minus 4. And on the right side, the square root of 25 is 5. What else could it be? It could also be negative 5, right? So we get D minus 4 equals 5, but we also get D minus 4 equals negative 5. So we have two equations again. The D minus 4 is the same in both equations, but when we take the square root of 25, that could be 5, but it also could be negative 5. The point in this solution that we split it up and get two answers is when we take the square root. All right, now we're not done. We still have to solve both of these equations. So let's just do this one first. If I have D minus 4 equals 5, what do I do to get the D by itself? What's that? Add 5, all right. So we're going to add 5 or 4? Sorry, add 4 to both sides. And when we add 4 on both sides, on the left side, those 4's cancel, leaving what?
D.
And on the right side, 5 plus 4 is? 9. Okay, so that's one answer. But then we have to go over to this other equation here. I'm going to draw my line of equality because I have to do the same thing on both sides of the equation. And what do I do to get that D by itself?
Same thing.
Same thing. We add 4, right? But it's going to end up being a little different because instead of doing 5 plus 4, we're doing negative 5 plus 4. So we get D equals negative 1. Because negative 5 plus 4 is negative 1, right? So we got two different answers here. This time our two different answers are not the positive and negative of each other like the first two were, but they're two completely different answers. And if we were to take these numbers and plug them in for D in the original equation, both of them would work. Okay, if we did 9 minus 4, we would get 5, and then we square it, we get 25. Or if we do negative 1 minus 4, we get negative 5, and then negative 5 squared is 25. So they both work.